Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing well. This is week 3 and day 1 of class 9th physics, and today we are going to study about the law which affects us every day, and that law is known as Newton's law of gravitation. In 1665, there was a first man named as Isaac Newton, who was an English mathematician who came up with the idea of gravity. He was trying to solve the mystery that why planets revolve around the sun and what is the motion of moon around the earth. While doing so, he had a question that what is the force that makes moon to revolve. He was thinking about it while sitting under an apple tree. And suddenly, an apple fell down from the tree on the earth. Now this sparked the idea that Earth attracts all the bodies toward its center. The idea of gravity flashed into his mind. He discovered not only the cause of falling apple, but also the cause that makes the planet to revolve around the sun and the moon around the earth. Now, as we know that gravitational force is a force of nature. Now you may think that it is as a force of attraction. That is because every object attracts every other object, whether that's me, you, or any other object around you. Because of gravity, you are being pulled by your book, by your pencil, or any other object that is around you. And you also exert a force on everything that is around you. So all the objects experience an attraction force toward all other objects in this universe. Newton concluded this law as a law of gravitation, or Newton's law of universal gravitation, which stated as that every particle of matter attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. You can conclude this formula from this definition. This is the force of gravitation, and it is equal or directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Consider two bodies of masses m, small m and capital M. The distance between the center of masses is r, as shown in figure. Now, as you can see from this formula, that law of force of gravity or gravitational force depends upon two things. First one is the mass of the body, and second one is the distance between two objects. So gravitational force depends upon two things. First one is the mass of two objects, and second one is the distance between the two objects. Let's see the relation between the gravitational force and the mass. As this force of gravitation is due to you and the objects having the mass. Whereas if the mass is greater, then the gravitational force will be greater. As Earth attracts an elephant more than a cat, because elephant have a greater mass and cat has a smaller mass. So gravitational force increases as the mass increases. So we can say that gravitational force is directly proportional to the product of the masses. And this gravitational force is inversely proportional to the square of the distance between them. Let's say that we consider two masses as m1 and m2. And d is the distance between the center of the masses. So this force of gravitational is inversely proportional to the square of the distance between them. If we combine these two equations, we have this equation, that is F is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And this was the definition of Newton's law of gravitation. If we replace this proportionality sign with an equality sign, we have to use a proportionality constant. And that proportionality constant is represented by capital G. And this G is a proportionality constant, or the constant, universal constant of gravitation, whose value is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kilogram square. From this formula you can see that F is the force of gravity, G is the universal constant of gravitation, M is the M1 and M2 are the masses, where D is the distance between these two the masses centers. So from this we can see that the value of G is so small, so we cannot feel the gravitational force. But if one object is very close to you and that object is very massive, then you can definitely feel that gravitational force of attraction between that object and you. And let's say that massive object is the Earth. Since the mass of the Earth is very larger, it attracts nearby objects with a significant force. The weight of an object on the Earth is the result of the gravitational force of attraction between the Earth and that object. We named that law as law of universal gravitation. Why do we name as law of universal gravitation? Universal means that this law of gravitation is applied on all the objects. Now let us talk about the units of force from this formula. As we know from this formula that F is equals to G m1 m2 divided by d square, and the value of G was 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. The unit of G is Newton meter square per kilogram square. So for G, we will write down the unit of G as Newton meter square per kg square. Mass m1 and m2. Both are the masses and the unit of mass is kilogram. While d is the distance between them and the unit of distance is meter. Now if we solve this equation and we cut the meter with the meter square with the meter square, and per kilogram square with the kilogram square, we will get the unit of force, which is in Newton. So the gravitational force is a force and it is also measured in newtons. Now what is the relation of Newton's law of gravitation and Newton's third law of motion? According to Newton's third law of motion, for every action there is always an equal but opposite reaction. As we know that mass m1 attracts m2 towards it with the force F, and same m2 attracts m1 with the force of same magnitude but in opposite direction. If m1 force is considered as an action, then m2 force will be considered as a reaction, which is equal in magnitude but opposite in direction. And this is considered consistent with Newton's third law of motion, which states that for every action there is always an equal but opposite reaction. Next we have an example on page number 108 and 109 of your textbook, and that example is that there are two lead spheres, each of mass 1000 kg, are kept with the centers 1 meter apart. Find the gravitational force with which they attract each other. Because There were two lead spheres and both have the same mass as 1000 kilogram, so M1 and M2 are 1000 kg. They are separated by 1 meter apart, so the distance between them is 1 meter. As we know from Newton's law of universal gravitation, F is equals to g m1 m2 divided by d square, where g is the universal constant, m1 is the mass of the first body, and m2 is the mass of the second body, where d is the distance between the centers, and F is the force of gravitation, or we can say gravitational force. By putting the values from the above data into this equation, we will get the answer as 6.673 multiplied by 10 raised to the power minus 5 Newton. Because the answer is in minus power, you can see that this gravitational force is so small. So that was all for today. Now your task for today is to learn the universal law of gravitation.